Good evening, everyone. I hope you all are having an insightful experience at the Faculty Development Program on Digital Forensics for Innovators, leveraging open source in cyber investigations. We are now on day 9, and it's fantastic to witness such active engagement from all of you. Today, we are privileged to welcome a distinguished speaker, Mr. Ajay Sharma, an accomplished professional currently serving as a senior technical consultant at upGrad, deputed at lovely professional university, Jalandhar, Punjab. Mr. Ajay brings a wealth of experience from both academia and industry, having previously worked as an assistant professor in the Department of Computer Science at Chandigarh University's Apex Institute of Technology. As an experienced research fellow, he has contributed significantly to higher education and academia, with expertise spanning biomedical image processing, machine learning, algorithms, bioinformatics, data science, anthropology, and international relations. He has actively participated in international conferences, showcasing his research through poster presentations and technical talks. His commitment to advancing knowledge in data science and related fields makes him a valuable contributor to this event. We are honored to have Mr. Ajay Sharma with us today and look forward to his insights. Over to you, sir.
Thank you, Ishika, for the introductions. Just let me know I'm audible or not.
Yes, sir, you are
Okay,
audible.
okay. Thank you very much. Thank you very much. Just give me a few seconds. I need to adjust few things. Okay, so good evening, everybody. So let me share my screen. Ishika, just let me know my screen is visible when I am able to share the screen or not. Just
Sure, sir.
okay, okay. Thank you very much. Due to rough weather over here, little internet is a little bit low in the university campus, so apologies for this.
So your screen is visible.
Okay, okay, okay. Thank you very much. Okay, so good evening, everybody. So my topic of presentation is image forensics, digital forensics for innovators, leveraging open source in cyber investigations. So as we are heading toward the end of this faculty development program, and might be the second last or last lectures for this faculty development programs. So here is the content of my presentations, which includes the basics of image forensics. Over here, we will dive into the historical evolutions, then type of image forensics, then we will learn about a little bit significance, why this thing is important to us. Then we have types of image forensics, just like I said. So we will deal with the source, camera identifications, image tampering detections, metadata analysis, and comparison and noise analysis. So image tampering detections, after that we are going to deal with the image tampering detections. So over here we are going to little bit about how cropping, splicing, object removals, and the use of technical techniques such as error level analysis, how we are going to do. And if we will get the some times, then I will give into the dive into the deep learning, also that how we are going to do these things. And then we will look into the comparison of noise level analysis, practical implementations. So before getting the opportunity to deliver this talk, I was thinking that what topic should I deliver, and what type of analysis we can do over there. So just by going into the details of these practicals with respect to the theory part, So I have searched on Google Scholar, and I came to know that there are few papers which are relevant over here also. So I have in over here, sir will provide all the supplementary material also. So I have added few articles. So my whole talk will be based on these 5 6 papers only. Okay, so with respect to in the end of this faculty development programs, these are very really interesting articles which I have found on different journals and uh, on the other websites also, Springers and these kind of websites. So my whole talk is based on these 5 6 papers which I've studied and which I have gone through with these for delivering this particular talk. So so if we talk about these presentations, so introduction to image forensics. So basically, image forensics deal with the analyzing and determining the authenticity of a particular image. What does it mean? It means that we have a clicked upon image, and there might be some kind of manipulations, tampering with respect to the data, and there should be some kind of hampering that should be done with respect to the image, and we are going to deal with this thing also. So it could be related to the falsification of the data. Then we are the wrong information should be interpreted with respect to the images. The actual images should be there. So that's comes under this category, and it has a huge advancements also going on, and it has a huge, this field has a huge potential also. So basically, if we deal about image forensics, so we are dealing with the meta-analysis, metadata analysis, then we have error level analysis also, and then we have a AI based some of the advanced detections methods which are available for us to do the image analysis. So coming to the importance, so sorry, it's a due to evolution of this technology, it is used in almost every domain, ranging from cybersecurity, media verifications, then we have legal investigations, then we have journalisms. So as we have a data and as we have a cameras associated with it, so whether it's an image, whether it's a video, whether it is no, some kind of 3D object, 3D image also. So there should be a way through which we can tamper, through which manipulate, and we can forgery the images and we can manipulate them also. So our part is to analyze this thing also, and we will come to know later on by this techniques that we are going to do it. So it has a huge potential and huge diversifications, because we have a data that is available over here. There are billions of devices which are connected through internet, and they are capturing the data on daily basis. We have a cameras, we have a video surveillance is going on everywhere. So it's a very important field to study related to the image forensics, and where we are dealing with the data, and where we are dealing with the tampering of the data, manipulation of the data, which comes under this category. So it has a huge importance also. And if you look into the historical evolutions of forensic science, then it's not a new term, because right now we have a huge penetration of internet, and we are getting a lot of devices and a lot of images which are being captured. But if you dive into the history, then it's not a new term. Okay, so with the 19th evolution of camera, and so we have seen that. So if we look into the historical perspective, so it has a huge history. Okay, so we will dive into. So I have added a few parameters, few points which are significant for this particular talk. Let me turn on my pen. So if you will see 19th century, that Matthew Offerman, a modern father of this forensic toxicology. So it's dealing with the modern forensic toxicology. So over here we have a department of biomedical engineering and forensic science also. So before discussing this talk, I have talked with them also that how type of matters that we can deliver to our participants, and so that there should be enhancement of the knowledge also. So I have took a little bit of help from department of forensics over here also. Okay, so and then we have a dive into 1823. So we have seen that there is a major fingerprint mismatch over there. So we have come to know that why this thing is important. Then we have 1859, so Alphonse Wellstone, okay, so father of this anthropometry. So basically these are dealing with the forensic science only. This is a huge evolution. So if we will look into it, so it's a huge evolutions of and now we are in 1970 to 1980. So we have seen that all the evolution is going on, and all the conferences and all the evolution, and now we have seen with the whole domain has emerged over here. We're dealing with the forensic science, where we are dealing with the image tampering. And then we have looked into the a little bit much more advancements also. So if you over here that Hans Gross has a pioneered in the first use of scientific study of the criminal investigations. So it has done in 1947 to 1915. So it's used in cyber criminal investigation also. 1902 Federal Bureau FBI, that's used published official laboratory provided for the forensic image tampering analysis also. And then we have a Florida Crime Act. So it's dealing with the criminal investigations. Again, we have IOCD, the International Organization for Evidence Collections, that how we are going to deal with the evidence collection. So basically, this is dealing with the imaging part also. And then we have a first FBI regional computers forensic laboratory that has opened in 2000. So then we have a SWGDE also, and then we have a Simpson Greek kernels, and then we have so it's a evolving field. And we will see that there is a remote digital forensics which are evolved over a course of a period of time. So it's again a detailed history. So what is the pre-digital era before this? So it was the first photograph which are taken by this Joseph Nefe, and is used in the photography. So it's the first evidence that has collected over there in 1926. And then we have 1860. So we have Abraham Lincoln's, which are the morphed photos. The first image manipulation event that has done over here period of time. It's dealing with the Abraham Lincoln's. And then we have early 20th century development of photographic forensics. So we are dealing with the dodging, burning, airbrushing. So these are the few techniques that they have. Dark rooms over here, the modifying images become common, including. So there are few processes that has done over there. So related with them again. Then we have photo intelligence also. Then we have film authentication techniques which are used over here to detecting the tampering in the forensic investigations. So this is again a little bit of history. And then we have Adobe that is introduced over here in Adobe, the Adobe Photoshop that we are going to use on for dealing with the images also a lot. Adobe. So 1988, and then detecting the forgeries and tampering also. So now image forensics. So this was the first event. So if you look at the history, so this was the image which I added over here. So it's a, I've seen over there that it's a tampered image. The original image was this was, and this one was a tampered image. Again, we are looking into this. So again, the tampering is there. Again, the latest example would be this one, in the tampering of the images. Actually, this one was a tampered image, but this was the actual image. So we can realize the importance of this image forensic topics, that how much important is. And even today, due to rise of this GPT and this artificial intelligence and this, some kind of this AI based tools, it will become very much important to diagnose and to deal with the image forensics also, because we have a lot of images which are morphed, and we have seen such cases in our daily news also, that this photo has been morphed, and this photo, and after 2 3 days it has to be done. So after 2 3 days we come to know that this image was not there, and actual image was this one, but still the loss has to be done. So 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 it's again techniques which are used. So we will look into it, and we need to be much more informed one, and we should able to get into the realities. So now we are living in a such type of world uh, where the things that we are going to see will not appear as it look like. So reality is different, and we will come to this thing later on. So till the loss has to be done, so we need to be much more aware about this thing also. And if you look into the uh, so significance of forensics, as we have seen in the first slides, that it has a huge potential. So we can use it in the criminal investigation also. Then it's a tool related with the deterrence also. Deterrence means that it has a potential to investigate all the things, and we can help a lot. This can help used in the cyber crimes a lot also. So it's used as a deterrence. So let's say if some country has a new type of technology, and we can, I'm sorry, we can detect with the help of this deterrence. So it's act as a deterrence also. Then we have a disaster victim identification in case of mass disaster, terrorist attacks, and war crimes. So it has used a lot over there also. Historical and archaeological insights, just like as anthropology. So in anthropology, we are going to use this thing archaeological studies a lot. So if you want to get the evidences, it's like as the old images which are present in the archaeology. So if you want to know that the what type of tampering could be done over there, so we can go to use it over there. Then we have cyber crime fightings also. So all sort of things should be available. Coming to the advanced, little bit advanced, so we have a basically different type of image forensics. Just like as a it has a huge, again, huge topic. So I will stick into the image forensics also, and we'll dealing with the imaging only. So if we talk about the imaging, so it has a source camera identification, then we have image tampering detections, then we have a meta-analysis and compression and noise analysis. So basically, we will go into the dive into these four categories also, just like as what are the source camera identification, image tampering detections, and meta-analysis. And then we have so if you look into the types, so again, it has a huge, but images should be used in every aspect of this thing also. Database forensics also, network forensics also, mobile forensics also, computer forensics also. So images are used in every aspects, but we need to identify the our digital image forensics also. So it's comes under the category. So there is a mismatch also. So it's a image, and then we have a videos. So image is a part of a video. So if frames are moving in a particular frames are moving in a particular second, so it comes under the category of a video. So image is a basic thing, and video is a little bit much more advanced things. So we need to look into the types of digital image forensics. So these are the few categories. We will dive into it, and the few branches also. So it has a huge domain and huge topics also. So it's huge in almost every things. So over here it is again saying us not related to the computer science only, or related to the forensic science only. It has a huge things also. So we can see that forensic biology, DNA extractions, DNA sampling, matching also. So little bit of image forensic should be used over there also. Then we have anthropology, then we have odontology, then we have pathology, that investigations, forensic toxicology, controlled substances, then we have actions investigations, and firearms, tool marks, then bloodstream pattern analysis, then the trace evidences, crime scene investigation, digital evidences. I have made this presentation in a such a way so that that someone wants to do their research in these things also. Sometimes we are finding some kind of problem, difficulty related to in which domain we want to explore the things. In which,
Sir, sir, I have one questions to you. The meteorological death investigations. Can you explain it?
Death investigation means this, like as if some person is getting died due to wrong diagnosis, or let me check, because I don't have that much of clarity on this. Meteorological death investigations. Yes, scientific inquiry into the cause of manner, so suspicious and unnatural death. Unnatural means that just like as a person is killing, so there are some type of natural death also. Then we have unnatural death also. Unnatural means just like as if someone has cut the throat also, or plucked the. So if we have that type of evidences, and that has to be sent to the some kind of medical labs, so we can investigate with the help of imagings. And these are the dealing with the some kind of forensic tools also, advanced forensic tools. So I have that much of a knowledge in this domain also, because that is dealing with the cyber crime and forensics also. So basically this is the things into that domain only. So I hope I have cleared your points, sir. And coming to our topics. So basically it has a huge things. Okay, so we can do the investigations over here also, and control substances. So we can apply the image forensics in these domain also. Also these are the highly sophisticated and uh, advanced tools are required over there. The advanced laboratories required over here, where the cyber crime investigation is going on.
But
So
today digital arrest is very much going on. So
yes, yes, yes.
do you think anyone is related to this part of digital arrest?
Yes, 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 sir, yes, sir, yes, sir.
If it is
Data.
if death is conducted in the hospital environment or ICU area, do you
Mhm.
think this is a part of meteorological death investigations or it is digital arrest?
No, sir, I am not able to. I am not qualified to give this answer because that is totally dealing with the medical profession also and totally dealing with the forensic science also. But yes, in my point of view, might be this might be because we need to collect the evidences also, and then we need to go into the in-depth analysis for this. So
Okay,
might be I'm not qualified to answer these questions, and I'm not. Uh, my expert area of domain also, and then we have a source camera identification also, or determine the models of camera for the captured images. So basically what we are going to do is analyze the sensor noise patterns, so photo response, non-uniformity, and then we are going to link the images also, and then we are going to compare the images with respect to reference databases. What does it mean? Let's say we have collected one image, and from one digital evidences that are happened in some kind of surrounding for the criminal investigations, and then we are going to compare with all the available databases. So what it will do, it will there is a search query that is fired over there, and it will look for the pattern that are inside the image that is available over here, and then it will give us the similarity index. So based on the similarity index, we will come to know that whether it is tempered or not. There are a lot of other parameters also which are used to judge over there also, but yes, this should be the one. So the person who are doing work over there, so they will come to know much more about this thing. But basically the idea would be same, that we have a one image, and it is searched throughout the whole criminal database which are available over there, and we are going to get the insights. So that means how much similarity would be there over there, and then it's used for the source camera identification. That what is the source of the camera means that that source, so it includes this like as a longitude, latitude, and then we have a day, time, so all the meta analysis that we are going to do. So I will provide you a little bit demo for this thing also. So and then we are going to use for the forensic image authenticity also. So we are going to detect the uh, authenticity also. Okay, and then we are going to deal with this like as a email and CFA image sensors, and then we have a incorporation also. So digital images is there, and then we are going to pre-process with the help of some electronic devices, and we are getting the output. So we have some source identification techniques also, just like as hardware based. Then we have a software based techniques also, so sensor based pattern noise. Then we have radial distortions and a color filter array. So auto white balance techniques should be used, image features, and machine learning techniques that we are going to use. So I think in previous sessions also a lot of discussion has to be done on this machine learning also. So if I will get the times, I have created one sheet also, so we will discuss on this also. Then we have image tampering detection techniques. So what we are going to do, we are going to copying, slicing, cropping, slicing, object removals, and then we are going to do error level analysis and deep detection techniques. So deep learning should be used over there. There are a lot of techniques, it's like a CNN is there, RNN is there, so a lot of algorithms which are available over there through which we are going to do the image tampering and detection also. So it will take some time also, but yes, I have created some practical demo. So I will quickly run into this PPT part also, and I will focus much more on the practical implementation also. So meta-analysis. So it's used for the XCF, the exchangeable file format. So basically, when the image has to be captured, so it is getting all the date, times, location, and camera settings that are used over there also. So it is captured the some metadata also, which are used for the further analysis purpose also. So if we talk about the meta-analysis, I will still remember one case that is happened on Facebook. So what they will do when we are going to upload the face, so it automatically recognize all the faces, and it will automatically tag you. So later on, let's say image has to be uploaded by some users, and 5 6 are users over there. So what it will do, it will automatically tag that features. Later on, there are some kind of privacy violation cases that happened over there on Facebook, and then they have later on they removed this particular feature from their systems. So basically it is avoidable over there also. So you can get much more insights over there also related to Facebook. So these are the metadata analysis, so they are capturing all this thing also. And comparison of the noise analysis, so there are a lot of noise that are available. Noise means there are a lot of distortion, lot of available in the noise when the image has to be clicked, and we will get this thing also. And then we have a metadata analysis, xcf analysis, so that we are going to do. And detecting an image manipulations. So basically we are dealing with the copy move forgery and splicing and resampling, and error level analysis also, and noise inconsistency and chrome aberration detection. So there are few techniques through which we are going to detect, and we are going to do the error level analysis also. And then we have a copy move forgery also. So if you are copying one pattern to another ones, and we are going to, so it's comes under the category of a copy move forgery. So this is the all theory part that I've added over here. And in copy move forgery we are going with the self containments, and then we are going to copy the content from one source to another ones, and we are changing the light, noise, and we are adding some kind of text patterns in that particular image, which comes under this category. And it has a lot of common use also. And then we are going to do the detection method also. Source variation splicing comes under this source variation also. So over here we are dealing with the lightning, texture, and noise, colors. And then we have a forensic channel, and just like as edge inconsistencies. Basically what is it is all about. Let's say we have this image and this is our pattern. So image is composed of pixels. So what should be that values over here? So it is edge inconsistency, so it is dealing with the kind of pixels. And then we are going to light analysis also, and then we are going to apply deep learning techniques over here also. In resampling we are dealing with the interpolations of methods. Then we have a tampering detections, and then we have a usage of image editing softwares. And then also over here we can see that this is an example of copy move forgery. So this image is a tampered image, and this is the object has to be copied over here and here. So it should be come under this category of copy move forgery. Again we have this thing available over here also. So it has a copied, and same pattern should be available over here, so it should come under this categories. So this is the copy move for forgeries. And again we have a if you will see in these images, so we have a source and we have a targeted images. So again it's the inspector. So we are going to, so we will look into the patterns of that particular image, and with the help of this pattern and with the help of these edges we are going to detect. Over here it is visible over here, detect and manipulated images and ground truth, that is available over here. So it comes under this category of source image. Okay, so again so if you dive into the deep, so if we look into it, I think yes, okay. So if we look into it, then we can see that it's a 400 dpi, so means much more pixel intensity is available over here. So if we draw an image, let's say we have drawn this image available over here. So how much edge should be there, edge consistency should be there. So it's we need to detect this thing. It's comes under the category of edge detection also. We are going to use in a lot of things, has to be used in biomedical image processing also, when we are going to deal with x-ray, mri also. And it's a category that how the image has to be drawn. And again if we have a more dpi images, so let's say we have a same image should be available over here, and we are going to detect. So again the edge, the more the pixel value would be, the more the value we are going to get. So this should be the idea. And on the basis of this, if there is a distortion in a particular image, so we are going to detect the edges that are present in a particular image, and we are going to detect this thing also. So this is the idea. And if you will see it over here also, so we have a 1000 by 500 pixel image, and we are going to see that edge detection that is available over here. So it has a huge, again, so if there is a tampered image, or if there is a image which has a manipulated ones, so what is happening over there? We will see that the edges are not sharp or not smooth. So there should be a blurring of images should be there. Okay, so that's the idea through which we are going to detect the tempered images, and we are going to look into this thing also. So these are the few screenshots, and over here it's a map image which will show in-depth analysis also. So see, if we are going to zoom it, so how this thing is going on over here, over here, over here, over here. So this is the idea through which we are going to see that whether it is a tampered image or a what we can say the original image. So there is a smooth mixing of pixels, although there are some tools also, but yes, there are some variations which are present over there through which we can detect, and we will see that we are going to get. And again, if you will see on the Photoshop, so Adobe has some kind of features which are available over here. So I have put these screenshots from the Adobe sites. So they are dealing with this pixel intensity, and this all short kind of things should be used for the edge detections and the tempering of that particular images. Although we have a rough and smooth kind of filters which are available, but still if we will do the histogram type of analysis, then we will get this thing also. And again, the new kind of method which are dealing with the hashing and signatures. So basically when an image has to be generated, so there are two type of cryptography techniques which are used over there. So MD5 checksum is there, then we have a secured hash algorithm which generate 256 bit of code through which the image has to be done an image. So let's say we have one senders, and we are sending some image. The hash algorithm will be available over here which are generated hash hash functions, and on the basis of this the key has to be done, and it has the image has traveled through the internet, and the source over here, the decryption algorithm will work. So if the match is found over there, then it's a original image. If there is some kind of tampering has to be done, then it's a tempered image. So if the hash value has changed a little bit, let's say how this thing will work. So let's say we have one image that I will show you that in a small code also, that how we are going to detect this thing also. There is a small code that I have present over here. Let's say we have one image that is present over here, and let's say it's a 250 cross 250 image. So pixel value would be there. So it's a so when we are going to process, and a hash function which is associated with it, let's say a value has generated, let's say a value abc D has generated for this, and this is then we have a key that is used to, and then when it is generated over. So let's say in when the data has traveling through this network from source to destinations. So let's say you have seen that in Wireshark protocol, and there are some other tools also through which packet filtering has to be done. I think in the previous sessions these type of things has to be done over there. So what would be that? Let's say there will be a little bit tampering of this pixels has to be done. 250 pixels, 250 cross pixels. So if we are going to tamper a one pixel out of this whole image, the hash value will change. Let's say it's a 5D and it will become 51. So the simple code would run at the back end, and say if you are saying that this code is matched with this one, then we have seen that the information that we have sent is exactly this one. Otherwise, it's a tampered. So this the basic thing has to be done over there, and we are going to deal with the digital signatures. So these are comes under the category of digital signatures and hashing techniques. So basically MD5 and SHA-256 is the one of the most advanced algorithms which are used to detect the tampering with respect to images. Although this hash function is used in a lot of other variations also in websites, also other kind of manipulations also, and to sending the data, to send the transactions related data, banking related data, but it has a one aspect related to the image processing, and related to the forensic science and imaging also. So there is some cryptographic algorithm which will run at their backend, and it will generate the code hash code. So I will show you that how they are going to generate this code also. There is a one company Cloudflare, and they have used some innovative techniques so to generate this particular code, and every times the unique code has to be generated. So I will give you that path also. Again, it has a huge integration. So this is a little bit of theory part, but I will not dive into that much more. But yes, it's used for the data integrity, and then we have a secure authentication, then we have a collision resistance also. So it's used for the collision resistance if there is some kind of a data filtering issues that are present over here. So if we detect the same hash value or different hash value, so it should be considered as a uh, tampered image, or we have a some the high source data that is available to us, the originality of the data. So if it is a tampered one, so it should be done. It is a original one, then it should be done. Then comes to the image integrity verification with the help of hash function also. So I'm sorry. the hash function is used over there for the tampering detection, and then we have efficient comparisons. So cryptographic hash tables are used over there for the image full scans. So these are the techniques which are used over there. And then we are going to this minor changes also. So if we will look into the algorithmic part, if uh, uh, if you will get the pseudocode of this thing. So if there is a simple logic, that is, if md5 checksum which are generated over there, if we will matched over there, then we will say that it's a equivalent one, otherwise it's a generated one. So it has a 128 bit of uh, code that has generated, so it has a huge permutation and combinations. And sha256 is again 256 bit of code that is generated, and it's used in front of the data, and then your data has to travel to on the internet, and we are getting the results. So same thing will happen over here, just like the plain text we are going to use. So for us, for this our scenario, we have an image, and then hash function is available over there, which are added over there. So we can use both the things. We can use so we can use both the things also. And the hash function should be used, md5 checksum will be used. Excuse me, sir. Okay, thank you very much, sir. I think there is some kind of distortion that is present over here. Okay, so basically coming to the hash functions. So hash function are used over here, and then we have input parameters. So hash functions we are going to add, and we are getting the let me take my pen again, and this is a hash function check. So I will show you that how we are going to generate this hash function also with the help of one code, and then we are seeing that we will see that how the manipulations has to be done over there also. So same the pseudocode which are used for the detect the integrity and verification of the hash functions. So integrity and verification of the hash functions, so it has again we have a lot of examples which are available over there. So DNA samples, or the criminal investigation, or the cyber crime investigation which are going over there. So we have a reference images, and then we have hash table databases which are matched over there. So let's say there is one image, we are working on the biology, or we are working on the cyber crime investigation, or someone is working on this type of research xyz. So we are there is some kind of fixed hash code which are generated for this particular data. So if this is going to match with this one, then we are going, okay, so we are going to fire the query over here also. Query means the results or the samples that we have generated from here. So we're going to analyze this thing. So if the both the thing has to be matched, then we can say this thing has to be done okay, otherwise it's there is a tampered image. So it has again to check the integrity and verification of the hash functions, this technique has to be used. And this is a small pseudocode, not the actual code, but yes. So original image we have there, we have a recovered image, then we have a hash function sha256 algorithm. So we have original and recovered image, and if the both are things has to matched, then we can say that image is intact, otherwise image is altered. So basically if else formula would be there. So so in computer science we have studied this in first year, or that first year of the engineering, that both the things are mad than this, otherwise to do that. But yes, it has a huge application also. So it is used over here for the detecting this thing also, that is altered images or not altered images. Then we have duplicate images also. So if we can see on the internet that there are a lot of image forgering has to be done, and we have a duplicacy of the images that has to be done over there also. So we can detect how we can. So let's say some picture is going on this one, okay, and what it will do, it has to be done in that way. So the pixel intensity has to be reversed totally. So it is the original image, but is a duplicated image also sometimes. So how we are going to detect? The pattern will always remain same. This one. So we can, with the help of some certain algorithms, they are able to define. So it's again a research, again a field of research, that how we are going to do it and how we are going to apply. So if you will see over here, this is one image, source image, and we have a grayscale image also. Although both the images are same, but we have some kind of changes related to the pixel intensities, the pixel functions which are available over there. So we will see that the altered image is there, or the same kind of image, or the changes value, or the hash value that has to be changed over there, it is present over there or not. So this thing has to be done. So this is the way that we are going to work upon, and we are going to deal with the detecting of duplicate images with the perpetual hashings. So this category, so it's again we can do a lot of research in this area also. So if you someone want to work upon this thing also, again there are few case studies that we are going to look into, that how this thing has to be done on the real case example scenario. So I have a small collab sheets which are available to us, so we can use in the fake news detections. Just like as a if we have images, so on the social media we will see that a lot of fake news are surrounding over there also, a lot of fake images. So this one I have talked about this in this our talk, that where 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 over here. So if instead of this image to be circulated on internet, what would be the impact? A huge impact. Okay. So because as you know, Iran versus USA, so there is Abraham Accord which is signed over there, and then we have all the things. So nuclear treaty, the US is imposing on Iran. So they are looking for their nuclear warheads also. So America is opposing this thing also. So if this image has to be circulated on internet, then see what kind of consequences would be there with respect to till their organizations or their media team didn't verify this thing. So it has a huge fake news that are circulated on daily basis, and we need to work upon, and we need to check the authenticity and the reliability of the images, and all sort of things that is happening in our society today. So it has a this case study. Then we have a cybercrime investigations, as sir has said and asked the questions that what we are going to do cybercrime investigation. So there are a lot of cyber criminal activities that are the images are morphed. Okay, so they are circulated on internet on daily basis. So we will do, then we have a legal law enforcement applications also, because once we are done into this cybercrime type of investigation, so we have a huge judiciary that has to be involved over there, and then we have a lot of interpretation that has to be done related to the law and related to the legal insights of this, although it's a domain of computer science. But yes, cyber law, cyber forensics is dealing with the, then there is a indulgement of legals and forensics also. And then we have forensic techniques used in journalism a lot. So it's again a field where we are going to get the evidence data. So we have a journalism, the reporters which are basically dealing with the cybercrime investigations, or the or other kind of murders, or other kind of things which are happening in our day, in our daily societies. So it has a real world application also, and it is a huge challenging thing also, and a lot of cross globe every government is working on this thing also, and we need to give much more awareness to the publics also, as well as in our day-to-day life also. And then we have a practical session overview also. So I will after a couple of minutes, I will look into this practical session and demo also, that how we are going to look into the libraries, and how we are going to do that. There are some Python codes, the small Python codes which I have developed over here, because it's a huge thing, and I don't think so within a 2 hours we are going to uh, get much more insight. But yes, we will get as per my knowledge, and as per uh, the the resources which I have available over here. So we will have a good understanding about image forensics also. So we are going to deal with the detection of image manipulation using ELA, and then we have detection of image forgery and perpetual hashings with the help of image similarity detection, that how we are going to the similar images we have. And then we have a summary conclusions. So without wasting any of my times, what I will do, I will directly jump into the practical sessions, as I was instructed by Dr. Abhishek that we need to focus much more on the practical implementation or rather than theory purpose. So we will dive into the practical implementation for this thing also. So these are the summary, and we have learned about this keynotes, and then we have a little bit of question answer sessions, and then we are dealing with the dive into machine learning, deep learning aspects also, if we will get some times. And then we have a so so if we talk about the coding part, might be there might be some persons who are sitting over here that that they don't have that much of uh, uh, knowledge or their much knowledge of computer science, because there might be some persons who belong to some another domain also, because these topics deal with a lot of other domains also, relating with the biology, also relating with the biomedical engineering, also related uh, with the department of forensic science also. So might be there might be some students sitting over here for the masters also, some PhD scholars also. So let's dive into the basic one, that how it will look like. So there are a few websites, there are a few repositories through which we can get into it, and then we will dive into the deeper understanding about this thing also. So so what we will do, we will uh, check into the, there is a one website. So I will provide you the PPT also, and provide you the codes also, and all sort of things which are available over there. So let's say if you will go over there, so let's see, these are the little bit to develop your interest. So well, I was get opportunity to deliver this talk, so I will look into that how we are going to detect. So we will go from basic to advanced levels. So this is the one websites, the open website available to all the things. So all the codes or all the things are available on online, and we are going to see how it will look like. So we have one image. So this is a standard image. We will work upon our image also. So I have created few images also. So this is the image, and we will look into the quality. So I will give you the clarity also. This is an UFO mean unidentified object, which are present over here, and this one is the object that is presented over here. It's a morphed image, means it's not an original image. You can see UFO, so we have a don't kind of no kind of thing UFO is there or not. So, and it is in front of the city also, so we have no evidence of this thing also. And then there is a person who is doing this kind of skydiving also. So he has jumped from some kind of aeroplane, and he is, so this are the two evidences that are present over here, which shows that this is an morphed image. So the basic thing would be that how we are going to detect this thing, that is a morphed image, or there is kind of some kind of tampering that has to be done over there. So basically what we are going to do, we are going to look for the histogram analysis. So histogram means, what are the histograms? Let's say if I will open my PPT, and let me uh, take one this thing. So what the histogram means? Histogram means that we have data, and how this data has to be segregated. Okay, so with the help of this analysis, let's say earlier we have one image, and color correction should be there. Let's say these are the colors. So by just looking into the some histogram, let's say my signature is this thing. Okay, and so let's say some tampered images should be done. So how I will do, I will done like this. So if some person will be doing like this, so it's a histogram will become little bit different. Okay, so histogram analysis would be that the same error code should be there, and there should be different ones. So it should be done with the help of a histogram. And in image processing, the first task, that first lab that we are going to learn about, this is histogram equalization. So it's a color correction techniques also, but yes, if there is a lot of evidence tampering that is happened in this case, so we are going to do this histogram analysis also. So we will see over here. Okay, so let's reduce this histogram equalization, and then it is going to auto contrasts also for this thing also. So I think I have a lot of small internet, but it will take some time. And then we have auto corrections. So it comes under this category of histograms. So with the help of this histogram equalizations, we will deal with. And then we have this clone detection. So if there is some kind of clones, so see, there is some kind of output that is going to be generated. So see, if there is a minimal similarity, means you can see that these two clouds, this one cloud and this one cloud, we will get these are the similar ones. So with the help of this minimal similarity, so we can create the code for this also. I have created the codes also, but yes, with the help of this GUI based interface, it will become much more easy for us. So we have a codes also. So we will see that over here that the clouds are bit similar, and we have a similarity over here also. So this should be the act as a practical implementation also. So if, let's say, if one image has to be clicked over there and we want to see that how much tampering has to be done over there, or let's say if there is some kind of uh, uh, object that has to be added over there, so we will detect with the help of this thing. So over here we can see that this is a one cloud, and that is also a similar kind of cloud should be there. So this tampering of images has to be done over there also. This is a tampered image. Okay, I have also created my tampered image also. We will look into that one also. So this is a similarity. Okay, so over here we will see the similarity index also. Then we have a minimal detail. So this will, so while looking into it, just this is an online tool that is available free of cost also, so people have developed. And then we have a cluster size analysis also, how much cluster size would be there. So let's say a copied one, this one is copied, let's say we have copied over here also, so it is giving us that image also. And then we have a block sizes. Okay, so this is just giving the insights also. So you can play with it, and the who are the basic one learners, so they will get much more insight. To those who are in the advanced ones, and so it should be act as a basic practical demonstrations also. So then we have a image resizing also. So this has to be done also. So image sizing, how much clone detection. So these are the tools, and one can work upon this thing also. So if someone is doing their research work in this area and he's working over there, then we can improve these things, and we can work upon on these type of topics, and we can get much more insights over there also. And coming to the error level analysis, so see, the image which are captured over there, it has a, so we have a jpg quality, and then we have, so there are a lot of images which are present over here. So we have a jpg image, we have a png image, we have a tiff images, we have a lot of file formats which are available over there, so which are dealing with the different kind of analysis. So what we will do, if we will do the error level analysis, so we will see that UFO, the unidentified object which are present over here, it has a different patterns, different color schemes which are present over here, and over here also it has a different color schemes, which will indicate that these are the, this is a morphed image. Okay, and then we have error scale also. So how much error we are going to add. So that should be there. Okay, so we will see, and this tool or this website should act as a basic interface to learn about this thing also. And then we have opacity also. Okay, so this thing should be there. And then we have a noise level analysis, the noise which are present in our images. So noise, there is a salt and pepper noise, there is a Gaussian noise. So there are a lot of different uh, dots which are the salt and pepper noise, which is a basic one, just like as the dots, black dots which are appeared over here due to lightning and all. So over here we will see that all they have a same type of kernel, but the image which are added over here, it is showing the different type of color schemes. So with the help of this noise analysis, sometime in image processing, we will deal that we will say that noise is not a good term. Noise is not, but in error analysis or in cybercrime investigations, we need to look for this thing also. So with the help of noise detection, also noise analysis, also we will get the much more insights over there also. And then we have a equalizer of histograms. So these are the, a lot of tools which are available over there to perform the noise level analysis. So then we will see opacity also. So this is this thing we can do, and to develop this kind of tools, the programming that is worked at the back end, but in the front end, the all sort of programs has to be worked over there. So HTML kind of things should be there. Then we have levels. So illuminations. With the help of this thing also, we will come to know that whether it is a forgery or whether it is a safeguard. So illuminance. So with the help of, we will see, and this technique should be widely used for the error detections and the falsification. Then we have a illumination, luminance gradient also. So we can explore. So opacity also. And then we have a PCA, the principal component analysis, the techniques which are used in machine learning a lot, and it is using the input would be color and the projection would be that. What would be the difference between two? So over here we will see that if you are doing the PC analysis, then input is our color code, and the difference would be, so So this technique used a lot. Okay, so see, if we are going to deal with the original ones, and if we are going to deal with, so with the help of these techniques we can word, and then we have equalization also, and then metadata, the data that I was talking about over there also. So we have one websites for this thing also. So metadata, so metadata is the data which is associated when the image has to be clicked. So a lot of metadata is available over there. So from which devices it has to be captured. Then so I have created one lab also, and then we have a GPS longitude, latitude also, and then we have these all sort of things which are the ISO forms that are available to us. So where the date, time, and then we have a software that are used over there, the resolutions, the how much resolution size also. So this is the data analysis that has to be done at the back end, and then we have a geodata, means where this data has to be done. This image has to be clicked, the latitude, the longitude, the earth size, and then we have a, so if you will go and open the street map view also, so it is going to detect also. So I will show you that how to prevent this thing also, but yes, we will not uh, do this for every time, every images. So, and then we are going to do the thumbnail analysis also. Okay, thumbnail analysis means that that how it will work, and that how it should be visualized. So we will have one image and we have another image also. So it's going to do it over. Then we have JPEG analysis, also the quantization of images like a histogram, equalization, and quantizations. So these are the image related imaging part also. And then we have a string extractions. That means we are going to extract the data, and based on this, we are going to get the results. So this much of information has to be done over there. So this much of amount of data a company can capture based on the image that we are going to do, that is captured by some type of cameras. So this is the huge data that is associated with it, and we are going to detect. So this is a very good website which I found out to do this type of analysis. And if you are going to upload your own file also, so what we will do, we will upload one file. Okay, so for this class I have created one small codes that are present over here. So if you will see, then so see, the all it is showing the realme, the all the detection of all the codes from when this image has to be captured, and what are the metadata that is associated with it. So for preparing this class, I have clicked a few images, and I will show you that one, that few of the tampered one and few of the changes also. Okay, so if you will go over here, so this was the image which I captured at MH Military Hospital Jalandhar, nearby Jalandhar. So this was the original image which I have captured over here. So I have created 3-4 forms of this particular image, and we have learned on this image only. So if you will see the clone detection, although there is a no changes, but yes, the fabricated one was different one, and block size would, so this thing is giving just like as a some kind of, so over here, so my camera has changed this wire or say some kind of objects when I was capturing this particular image, so it has changed over there also. So that's why it is showing some kind of things, although these are wires, but at that time some kind of flying object would be there over there, so it has changed when capturing. So if you are doing the error level analysis also, so again we are, by this format we can change. So I will provide you the image also. I have provided the links also, so later on when this lecture will open over, we you can just visit over there also, uh, uh, and then play with this thing also, and play with that website also. So coming to there is a one next website also. So this one is there. Then we have a photo forensics also. Okay, so this one is again a very good websites which I have captured over there. So so to prepare this particular lectures, what I have asked my colleague to give some photos, click some photos from their phone. So she has iPhones, and she has sent to me. And if you will look it over here, so upload photo, and I uploaded it, uh, and upload files. So it will do all the analysis for us. So if you will look into it, so what is happening over here, let all the error type of analysis has to be done. So error level analysis. So if there is some kind of forgery or there is some kind of tampering that has to be done on this particular image, then we will come to know that this is a tampered image or this is the original image also. So there are a lot of analysis that we can do, just like as a EL level analysis. Then we have a games also. Okay, then we have hidden pixels. Let's say if there are some kind of hidden pixels that are presented over here, and if some kind of hidden informations which is to be presented in this particular image, we can do this thing also. So it's the error level analysis, and with the help of this we will see that there are some kind of hidden pictures. So let's say some cyber crime investigation, what is should be done over there, that they are sending some kind of hidden pixel data. So all the information has to be stored over there also, but some kind of images has some kind of pixels. So based on this, the pixel intensity has to be done over there, and this pixel has some kind of a unique. So this kind of techniques has to be done. So it's a part of cybercrime investigations. So all the person belonging to the police, just like as this all the CBI and all kind of cyber criminal investigation agencies. So they have some kind of sophisticated tools and some kind of hardware, so through which all this thing has to be done, and the decoding of all the code has to be done. So we have a limited resources over here also, and limited uh, kind of things, but yes, with the help of this hidden pixel techniques we can detect this thing also. So we can write the code for this thing also, but yes, and someone can work on the image processing and machine learning part for these techniques. Then we have ICC plus also. So it is giving us the, so no profile, nothing has to be done. Okay, so it has a nothing. Then we have a JPG percentage, JPEG compressions ratios. So how much JPG compression ratio should be there? So there are a lot of standards which are used over there for JPG compressions, and with the help of these techniques we will get the so there are small code which will run at their backend, and it is giving us the output also. And then we have quantization tables through which the compression ratio has to be worked on JPG images, because we will see that when an image has to be captured, so it is capturing all the pixel values, and it has some size also, just like a TIFF image is there, we have a PNG images, we have a JPG images, we have a lot of, we have a PSD images format is there. So each image compression use different type of technique, different type of learning method which are used over there, and which is doing the analysis also. So it's come under the JPG compressions. So it has a 80% of the quality that is present over here in the JPG compression. So if I will upload the different image, so it is giving us the different value also. Then we have a meta-analysis. So again, the meta-analysis, so we have codes that are present over here, so it is not giving that much of informations. It is showing the JPG images here. So it is showing that we have a JPG image, and the width of the image and the height of the image. So with the help of this technique only, and then we have a, then coding, there is a Huffman coding technique which are worked over there. So if some person is for the electronics backgrounds or some kind of background, so they, so it's a coding techniques, encoding and decoding technique, Huffman encoding techniques which are used over there. Then we have progressive DCT technique is there, discrete cosine transform is there, so which are used over there, which are transforming the images, and so it's a typical electronics kind of things which we are. And then we have a bits per sample, and then we have a color components, y, and then we have a yellow. So it's a sampling, YCBCR, and there is some sampling techniques also, just like the RGB is there, that just like as a cyan is there, yellow magenta is there. And then we have a GIF versions, just like how much resolution would be there, composite side. So this all the, and what would be the megapixels. So the metadata knows that how much megapixels of your camera has. Okay, so it has captured with the help of this 1.4 megapixels cameras image. So my colleague has some small phone that are available over here, the older version of iPhones. So that has this much of cameras. So So we can't hide the things. Basically, if we will look into the metadata of a particular image, and then we have a string values also. So it has again the string value which are associated with it. It is going to be happened over there, and this is the metadata analysis which are used for the detection. And then we have a source. Okay, so source is not going to detect because we have removed all the sources also, and we have gone through all the things. So this is a very beautiful websites on which you can work upon, and we will see that how the metadata and how the analysis has to be done, and we can work and we can write a code over there also, and put it over there, and we can do the things just like as a digest. So it is creating some MD5 checksum also, and SHA algorithms. SHA1 is there, SHA256 algorithm is also there, so they will run at their backend, and it is used to secure the authenticity of a particular image. And color channel would be that 3 because it is dealing with the RGB color channels that we have over here. So basically it's a good websites and good tools that is present if someone don't have want to take the interest over there, or to just want to know that how it will look like. So it's a good thing for them also. Okay, so then we have much more websites. So uh, one second till I will run this system. There is a one more good websites that are dealing with the metadata. So if you want to, if you don't want to write the codes, or if you don't want to just you have just want to play, and you just want to see that how this thing has to work. So what you need to do, you need to just go over there and choose the website, and let's say we have choose one image. So this one is one image. I will give you the brief description also, that how which one is tampered one, but this one is original one, the 314. The end size is 314. So if we will upload this particular image over here, and if we will see, and uploading is completed, and if you will see the metadata of that particular image, then we will see the metadata also. Although we can do this thing with the help of code also, but not everyone is expert in the codings. And although the same backend code will be work over there, which I will show you within next 10 minutes. So checksum would be there, and the image size. Then we have a file size, how much file size of a particular image has a. Then we have a JPG image, the extensions, which type of extension it is going to create. Then we have a MIME type. Then we have a exbyte order. So it is using this type of orders. And then we have a from where the device has to be taken. So it's taken from this device. Then we have model number, then we have horizon, then we have resolution also, XY side resolutions, how much the units, and the to see they will capture the MediaTek camera also. So you can't hide there should be no privacy at all if you are going to collect one image. So best thing is we need to remove the metadata also, but we can do for one image only. But we if we are going to get capture 100 images, 1,000 images, so it is very difficult to be to protect yourself also. Then we have at which date the modification has to be done. So and then we have add a time also, and then we have a exposure ratio, exposure time. So what would be the exposure time also, they will know this thing also. Those who are into the photo industry, they will know that what is the exposure time also. And then we have exposure programs, ISO, what is the ISO values. So this again a sensitive type. So this all sort of thing has to be collected. Just like the offset time of originals, when this time, so it's original times also. Okay, so because it's evening times, but it's showing some 530, so original setup time. Then we have shutter speed. Even they are going to get the shutter speeds also, aperture values, what type of settings that I have kept over there at the time of capturing the image. Even I don't know this thing also while clicking this particular image, because I have clicked on the random basis. I'm just going through this at a military hospital, and I found this an interesting one. But yes, so brightness values, the all the so this should be act as a metadata, the light source. Then we have a focal length. what would be the focal length, then we have binary, then we have sub second time, original time, then we have color space, sRGB, then we accept image width, what would the width, what would the height. So all the data. So see the how much data that the photo, when we are going to collect or when we are going to click, that has to be captured. So then we have a compressions, JPG, old style. Then we have thumbnail offset. Then we have image width, image height, and then we have encoding technique. Which one encoding? So discrete cosine transform, and then we have Huffman encoding that we are going to use. What is the bits per sample? Color components, and then we have aperture ratio. So it has huge things that has calculated over there, and then we have raw headers that has to be sent over there. So I don't know for what category this has to be used, but this sort of information has to be done. And now what we will do, we can save this thing in the PDF file also. So 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 we can save this in the PDF. Okay, so and then we can produce the evidences also. So if someone is doing this kind of things, and we will tell them that you have done this, and this should be the output for this thing if they don't know. But yes, we can change this metadata also. That's the uh, uh, problem also. So what we will do, again we will go to that website, and let's copy and paste it over here. Metadata removers again. So what we will do, again we are going to select our own standard file, and it is going to okay. So now the information we want to remove. So now this website will remove the metadata, and we will download it. Just by downloading it, and the data has to be removed. So this is a very beautiful websites, and let's say if they will able to remove it. Earlier they have removed, but now let's say if they are going to remove this metadata or not. I have put it over there, and let's say. So see, they are not giving any information about this thing, so it has to be removed. I think that's the thing, and they have removed the metadata also. Coming to our practical implementation also, so we have gone through with these three. Now coming to the fourth one, and it's a picture to map. Okay, so what it will do, it will map your values with respect to the locations that are present over there. So these are a few websites. These websites. So when you are going to do it, these website will generate your interest into this domain also. If someone is sitting over here, those who are a new one, uh, so this will generate their interest. Otherwise, if directly we will jump into the coding part, so it's a very. So see, no GPS information because I have changed it, and I don't know because why this is not going to detect. But yes, it will detect the image, and it will do the all the GPS information. At that time might be my internet is off because I will put the location of my phone is not always on. So I will turn it on off while always. So might be this was the case. But if you will put some another image, let's put this image. But I think for this particular demo we have removed the yes, no GPS because again. So uh, but if you will put some photo, then it will give us some GPS information also. So 1 second, let me. Okay, so I don't know, because of the university, this regulations, this website is not working. But yes, you can try. This will work, 100% work. It will work. Might be due to university, this internet. This website is not working. And then there is a one website on which you can change the metadata also. Although this one website is there, but yes, it's a website that will use to change the metadata that is present over here. Excuse me, just give me 1 second, please. So this one is a website, again very interesting one, developed by the Russians. Mm, the Russian developers. It's a very good website. It will do a lot of things also, but I will focus on only one part, that is dealing with the image forensics also, because we need to stick with that particular topic only. So if we will upload any image, and we will see and click on OK. So what they will do, they will see us all the data, metadata. So if we want to tamper that metadata, let's say I want to change it to iPhone 15 Pro. Okay, something like that. Okay, so what I will, let's say, I don't know how they have written the iPhone 16 Pro or 15 Pro, but I will do it. And manufacturer is iPhone. And what I will do, MediaTek camera applications. So let's say I will change it to Microsoft, or there is a software that are used for MediaTek, and there is a one software. Okay, let's change it to Microsoft only. I'm not able to recall at that moment which another software will do Microsoft, or let's say Google, let's say Facebook, for sake of simplicity. Date of last modification, we will change it to, let's change to 2030. Okay. The origin would be there. Then we will change the X resolution just like as this. Okay. And what we will do, the exposure time, the core sites, the not defined F number, ISO, let's change it to 10. Aperture, shutter speed value, and then we will do some kind of things. And what we will do, they are asking for the product ID also. The product ID is, we will add on the randomly, and then we have a dates and times, and let's, what we will do, we will so these are all the information that is comes okay, right, in JPG. Okay, so what we will do, we will download that particular image. So we have downloaded it, and now what we will do, we will the same image, what we will do, we will see that how it will look like. Okay, so let's change it, and what we will do, we will see whether the information has to be changed or not. What I will do, I will rename, and rename with the same image, same name, just like as this one, but I need to put a little bit different. But for sake of simplicity for this workshop, what I will do, I will in 2023, and rest is there. Okay, so we will change the location also, and this thing also. Okay, so let's change it, and so I have used this image 518. Okay, 1 second. Choose, and what I will do, I will go over here, and 2023. Okay, I think this was the image. Yes, let's say, what should be the outcome. Okay, so now our image has to be captured by the iPhone, and we have used the 16, 15 Pro model, and the software is Microsoft, Google, Facebook, and all sort of things has to be done to change this. So this should be the tampering and image analysis also, and this should be the best example that how we are going to change the metadata. But only those person will change this thing, those who know, because if you are going to this evidence tampering and this all so we will comes under the category of these laws, cyber criminal laws and all sort of things. But yes, we will, there is a one more question also, that how much information these companies are collecting while we are going to get the data. So again, it's a question between privacy and yeah, the work that you are going to do. So we need
Sir,
to.
these characteristics not so much contributed for find out if the illegal tampering of the images, because you are just changing the characteristics like 15i pro
Mhm,
or
mhm.
what is the data, but we cannot modify the main structure of the images, that
Yes, yes,
what
yes.
kind of texture or
Mhm,
what kind of
mhm,
illumination setting or type of
mhm.
gear you are using. So my
Yes.
sir, my question is that, sir, if you providing this website to me, so I can I explain, can I take some other images also? Another thing is that, sir, do you think that type of images you are capturing from the particular modality
Mhm,
during the time of uploading to this particular websites,
mhm.
there is any characteristics playing role by the modality of the images or modality of the devices for tampering the images?
No, sir. No, sir. So, what I can understand from your point is that you want to know that. So, I have normal phone which I over here, and I have clicked on the random basis. So, what
Mhm.
the thing would be that what it will do, it will gather some metadata at their backend.
Mhm.
So backend, where would be, okay, so this data has to be present inside the image, but it's not so if you will look into the properties of the image, so
Mhm.
we will see the some data, but this much amount of data that is present in that particular image. So let's say if I go outside and I have captured a beautiful image, just like the mountain image or something over there. So this much of information has to be captured over there, just like as a, who is the manufacturer, who is the model, who is the software, who is the other things. So this thing is also important when we are
But sir,
going to
can I take any legal action for the persons those who are tampering the images? Because
yes,
they may be denied that kind of particular this iPhone
yes,
15 Pro they are using.
yes,
So they say, well, better
yes,
quality camera we are using. So
yes, so
so there is. Do you think this sufficient information is better for capturing to finding the
no,
guilty of the particular person?
yes, but it will depend on the severity of the clause that has to be done at that time. So let's say if someone is person is let's say if some person is capturing a media campaign, the media campaign over happening over here, and they are just changing the metadata that is present at the backend. But if someone is doing normal thing just sake of the fun or sake of the things, then I don't think so that the legal action has to be taken. So it will depend on the severity of the cause that is happened at their backend, when this type of information tampering how has to be done, and how much loss has to be done over there while doing this type of a crime or civil crime investigation, because again this is a tampering of the data. If we are going to deal, and again we have a questions related to what is the what we can say that the our privacy, and the how much amount of data we want to give, because these devices that we have currently dealing with, they are just asking their permissions, and if we deny those permissions, then they didn't operate. So we have a questions over here that whether we should deal with the hamper our privacy, or we are not going to get the what we can say the subscriptions, or what is the features that is offered by that particular app or the device that we are going to use. So it's again a problematic questions, and our legal knowledge and our laws uh, has to interpret this thing, and our what we can say our politician has to work on this thing also, and our officers has to work on this also. So there should be a what we can say a framework, proper framework that has to be developed, that how much information someone want to give, because if we are getting this much of informations, it's a huge more than 250. So I have captured this image on random basis, so it's a 2 3 I think 2 years back. So it is giving capturing that if much, but I don't know, even I don't know, while doing this, running this image, particular image, they are just checking my software also, even though, so they have access to this thing also. Again, this is a matter, but although it's not a image tampering, but it's the associated data that has to be tampered with this particular image. So let's say some kind of scenario, imagine a scenario where some kind of rape victims or some kind of the photos which are collected over there, and it has to be done just like as if we will see in some kind of forensic movies, forensic science also, that they are capturing the images, and and they are sending for this image to some kind of forensic lab also for the verification also. So if they have these kind of much more advanced tools, we don't have that much access, we that the because that is the technology that is not available to layman persons. So they can also detect, but yes, some kind of fabrication has to be done, at least 15%, 20%, 30% fabrication has to be done by this thing also. So these links are available over here. I have all the ppts, and in the end I have imported these links over here also. So again, it's a very problematic thing, and we have to no answer for this thing also, because till we don't have that much of rules and regulations, we can't comply, and we can't work on this thing. So companies will do this kind of things, and we have no other options to safeguard ourselves, instead of just making uh, saving by saving just for ourselves also, and just don't rely on this. So this much of the information, so it should be the tampering with respect to evidences also. So these are the few websites. Coming to the coding part also, so I have discussed with sir also that how we are going to do. So if we will look into the code part, so basically these are for the only for the enhancement, knowledge enhancement, and how much we are going to do, but how this thing has to work at the back end. So that is the main thing that we need to figure it out. So I have created few codes also, and these are the papers. If someone is doing their research, so he or she can uh, uh, write. So if we will go it over there, so let's open up the part, the original part, or the crux of this particular talk. The things, how the things has to be worked at the backend, because if we have scripts that are with us, then there is no need to go online, and don't need to go for the. So what would be that this is a sheet that I prepared for the today's lectures. So what it will do, let me check. Image forensic XIF data demo. Okay, so just like it is again XIF data. So although you can get the information from this, but how this has to be done, because the codes which are work, and so what we will do, we will install one library which is called as below xread. So what we will do, we will run this thing. So although I have prepared all the codes, and it will take 1 or 2 days to make all these codes over here. So for the, because I have a limited time of 2 hours, and I need to finish up all the things over there. So uh, so we will go one by one also. So these code will work 100%, and I have checked twice, thrice also while running on different data sets. So you can rely on the authenticity of these codes also when you got the hands on these codes. So if you will see, then what is the pip install pillow and xfread. So this is a library, pre-installed library developed in Python programming language, which are used for the data analysis. So there are different library. Machine learning has different libraries. Then we have so it is depending on the user case to user case. So these are the library, and then we are going to import pl import image, and then we are going to use import tags and gps tags also, and then we are going to uh, run this thing also. And then we are going to define one functions, and over here what we will do, what is this function will do, it will look for the image path, and I'm sorry for this kind of disturbance. I don't know from where we need to turn it off. We are going to define one functions, and what it will do, it will open up the, just like the image dot open. So there is a dot operators and open the image, and what it will do, the path, the image path would be there. So it's a basic programming skills that we have learned in your bachelor's, that it will go over there and over there also. So it will directly look for the path of that particular image, and then if you are going to find the GPS coordinate, then it will do, otherwise it will return the values. Same thing, the simple if else statement would be there, and then we are going for the uh, I'm sorry for again this kind of disturbance. And then we have a get GPS info also, and then we are going to extract metadata and meta path also. So what we are going to do for this class, we are going to look for the camera models, date taken, and date, and editing software, which type of editing software, so if you are someone has going to use. So let's run this thing also, and it's a basic collab sheet, and you can work upon, and you can see and you can run that how we are going to do. So it is going to get the errors because GPS coordinate is not attached with my system. Okay, so but first of all, what I will do, I need to add my image. So let me check which image I have added over here. Image to, okay, what I will do, I will upload all the images in one go. So this should be done. I'm uploading all the images. Okay, so our system will detect automatically and which one image should be used over here. So it's a Google Colab repository, the online repository. Okay, so we are going to use this Google Colab a lot because it's a little bit easy as compared to the other one. Okay, so because there is no GPS coordinate, and then what we are going to do, we are going to extract the metadata. Okay, just like a camera model, camera date, and so what we will do, so it will, if available, extract the GPS data if it is available, and there is no availability of the data because we didn't provide any image. So till now, what is happening, the all the functions that we are going to execute, but right now we didn't provide any image. So now what we do, so in this function what we will do, we will going to provide the path of that particular image. So if you want to play with these sheets, so capture your own images and just replace this thing, this one. Okay, so replace your own image. So this comment would be there attached over there. So we are going to replace your image path. Okay, whatever the path would be, what you need to do, we need to upload the file over here. So when you are going to upload, and what we need to do, we need to copy this thing. Okay, so it is showing copy and paste it. Okay, so we have used this AMG, this one image. This is the original one image. Let me, because now we are going to deal with the data set part also. So I will, what I will do, I will show you the images in reality. So what I will do, this one is the original image which I have captured over there. Okay, and then these are the few images which are used, which I have removed all the metadata. Okay, this one also, this one is the university campus, and this one is the tampered image. So what I will do, I have created one these dots. It's a tampering which are available to us. So this one also. Okay, so this is a tampered image which I have removed by myself only by doing some kind of changes. So if you will look into the original image, this one is the original image, and and we are getting that. So this one is a tampered image because we have done some kind of changes, the visual changes that I have done. Visual means that it should be visible to us also. So I have forcefully done this thing. But sometime if you are going to hide the information, or you are going to add more changes, then it's a huge a different scenario. But this is for the demo purpose only. So this is our the typical image data on which we are going to perform some kind of analysis, and uh, so replace with your path, and then what we need to do, we need to, okay, so again it's editing software, but it is not showing the GPS location because my location is not on at that moment. So it has not captured. Okay, so again, if we are going to, so again we are going to run this the whole image. Okay, so content 3, image 3, replace with your own image path. So let's run this thing also. Okay, so again, because image 3 I have removed all the information. Okay, so this one is the image 3, because it is not getting any image, so I have removed all the images also, and then it should be, so it is not giving us the forcefully I have done this thing. Okay, so this is for the demo purpose only. And then what we need to do, we need to again install all the libraries, and this should be the work which we done again, the GPS coordinates. So now this image 2, let's say what it will do, it will showing us something or not. So while running this XIF data, this one should be there. Okay, so yes, so this is a what I have done, I have divided the whole code into, in one cell the whole code run, and in different sections the each and every function will run. So this is the way I have made it code, particular code. And what would be that that in one cell the all has to be done over there. So see the metadata, the xif data, so this should be the data. Okay, so with the help of the coding part, remember, we have done this thing over here, the photo forensics or the image to this website, this one website, this one, copy and just go over here and copy and paste it and see. So this thing, remember this website, this. Okay, so all the metadata that we are going to do, or all the data metadata that we have generated, it is presented over here, over here. So see all the informations. So with the help of this code also we can get the informations. Okay, so let's say you don't want to give your image to that any web repository, you want to do it by yourself, so you can do it. Okay, and there is no point in that. So it's contain all the metadata. So this one should be done, and we are going to deal with. So this is a small code, but it will do lot of things for us. So you people will surprised to know, in our university there is one thing would happen, that the students are using the fake OGTs on job trainings, and what they will do, they are creating the fake on job training certificates, and they will upload it over there, over on our servers, UMS servers, that is management softwares that is present over here. So the placement cell, what they will do, they will check this kind of metadata, and so I just accidentally recall this incident. So what they will do, they have tell that that particular student that you have used that Samsung Galaxy this much of the model for tampering this certificate. And guess what, they have cancelled their OGT for 6 months, and the student has to stay here for 6 more months, and he has to do their internship and all sort of things. So these are very small codes, but yes, they will create a lot of information for you people. So it's a good thing. So they have run, and they will check the metadata, and they will come to know that you have done this kind of forgery, and you have used this OGT, the fake OGT. So it's a problematic thing. The student will be in trouble after that, submitting the fake OGT forms. So this should be the examples that I recall at that moment. And then we have this digital signatures. So remember back our discussion over here on the digital signatures that are used over here for to check the checksum integrity. So cryptographic hash functions, MD5, SHA-256 algorithms. So again, very much powerful algorithms which are used to check the integrity of or the tampering of the data, because that is a unique code that is generated at every time when we are going to work upon. So it's a algorithms that is unique one. There are millions or billions of the chances on which one algorithm can run generate same hash code for that, but it's a needle in a haystack. So we can rely, and it has a much more advancements. So cryptography functions, hash functions. So this is a little theory part for those who want to learn much more about, because we need to stick to our topics also. So text is there, and then the hash function which is added over there, and it is going to generate the hash text functions which are used over there. And then we have SHA-256 algorithms. Again, the 256 bit of the code which is generated over there, and it is attached with our string could be anything. Okay, so it should be song, it should be software, it could be image, it could be video, it could be anything. So the algorithm which are attached over there, and it is check the authenticity of that particular uh, 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 things, or the particular software or image that we are going to do. So the hash functions that we are going to do is, it's used again security, spread perform, a use case has also there. So legacy application, non-cryptographic checksums, SHA-256 and MD5. And what we need to do, again, the small code that is going to work. So let's say I have created this thing. Okay, so let's say we are sending one text, and we need to generate hash code MD5 checksum of 256 256 bit encryption for this thing also. So what it will do, it will import this again library, standard library, and it is going to generate the uh, code. And MD5 checksum is there, as such a 256 algorithm is there, and based on this we are getting the results. So let's say, let's run this thing and get the how much hash code it is going to generate. So it is taking some times. Okay, so it is the same. Okay, let's say I just tampered this thing with some this. Okay, okay, the single changes, or what I will do, I will create one space, it's not visible. Okay, space is not visible for us. Okay, so now see, your MD5 checksum and SHA-256 changed. Okay, what I will do, I will, let's say I will change this thing, and it's creating, again it has changed. I think 4D or 5D is there. Okay, let's make it two spaces. It's not visible for us, but it is getting the hash code has to be generated. Now it has a huge potential. So if someone is leaving two space, we can hide the information over there also. Or someone is leaving three space, we can tell this should be the C, this should be the D. So the systematic cryptography has to be done by that. So if someone want to send the cryptographic message, or someone want to send this, the tampered image, he can do that. But with the help of this checksum code, we can detect this thing also. So that's why these are the most powerful algorithms which are detect over there, and it is going to give us the results. Okay, so again, so this is a geek for geeks, and if someone want to learn the difference between these and want to get much more insights, then you can go over there also. Okay, then we are going to see the authenticity. Again, we are going to check the our authenticity of our images. So let's dive into this, import all our standard images, and see. Okay, so let's say we have, now we are going to check that whether image has to be altered or not. Okay, so what I will do, I will, so see, both the images are different one. Okay, so because I have a shortage of time and I need to cover a few more topics also, so it is showing image has altered. Okay, and let's change this thing to this one only. Okay, so for sake of simplicity for this particular class, what we will do, we will assume that this should be the renaming also. Okay, so what will happen over here, if SHA-256 algorithm will work like this, modified, so this is original and this is a modified one. So we have this thing also, and otherwise it will be showing us the varied also. Okay, for this class only, for this demo only, I have created only this one. Okay, so it is showing no modification as detected because we are getting the same image. Okay, now this one is the same image for this particular demo. So let's run this also. If there is some kind of minute changes there, then it is showing the alteration also. But let's see. this thing. Okay, no modification. Yes, yes, it will run because I have renamed it. So what I have done, I have just renamed 4 over here, and both the images would be same, but we have two images which are available over here. Technically we have two images, but it is showing no modification as done. Now what I will do, I will change our the sample image, so that is the alteration has to be done. So with the help of this thing, that we are getting the getting the results. Okay, so this thing would be there, and then coming to the this again, uh, uh, yes, the Cloudflare. Okay, I have tell you this Cloudflare example also. So what this thing will be there. So to generate this particular code, what they will do, copy selections. I have one website. One sec. Cloudflare. One second. Cloudflare generate the light codes. Okay, so what they will do, this is a website which is creating the mm. so what they have these in their head offices, they have these lamps, ultraviolet lamps. Okay, so what they will do, the light has to travel into these, so infrared light or whatever the light would be going over there. So each and every time, these are 250 or something like lamps, so they are capturing, so the one camera is capturing these all the movement with this thing. Okay, so each and every time, the all the different md5 checksum has to be generated, and this is a very mind-blowing thing. So so we don't have that much of permutation and combination that all the lamps should be showing the same thing, same light, and again, and the pattern would be getting. So billions, trillions of parameter would be has codes has to be generated by this company, and they have a very excellent way of doing this thing. So they are the lamps at their head offices, and these are called 100 lava lamps. Yes, so it's a very innovative way to generate this codes, and they will rely on these websites also, and all sort of things has to be done. So it's a very beautiful. If you want to read this article, you can read. So I have just you need to put this thing also. Okay, so again, the no modification has to be done, and then coming to this part also. Okay, so cryptographic, the 256 algorithms checksum would be there. Okay, so that should be there, and what we need to do, we need to check the integrity. So again, I have added the few images, and uh, we need to check that whether two images are same or two images are different one. Okay, so by coding levels, if there is some kind of minute changes would be there, then it is showing us the alteration has to be done by the systems. Okay, if there is some kind of manual changes. So over here it is showing us the two images are different because I have already put two images different. So if you are going to put same images, it is going with those same images also. Okay, so same thing would be happen over here, and we are going to get the difference. So if images are different, and how much percent they are differing, hashing difference. So 20% hash is going to different over there, and it is showing us the difference also. Okay, so same thing we can get, and with the help of this, the entire code we are going to run, and it's giving us the same value. So these images are different, and how much different would be there, and how much difference in particular images we have. So this is a small sheet that will help you out while doing this thing. And then we have this ssh. I think I have run this also earlier. Let me check. Yes, the images are similar, the images are different, and then we have this thing also. Okay, so I think this sheet has also done. So this thing is all about what we can say, the images are different or images are same. So what we need to do, we need to add same images, different images, and we can check the integrity of md5 checksum also, and sh256 algorithms also. There is a one more sheet which I have made it, but it will take a lot of times, and I think but I will give you that insights also within 2-3 minutes, because after that we need to send the few times for the question answers also, and it's very much important. So basically what I have done in this sheet, so we need to integrate the machine learning and deep learning models on this, how we are going to detect the image forgery, and how we are going to do the analysis related to image forensics. Okay, so what I have done, because let me close that also, that one also. Yes, so I have got one Kaggle data sets. Okay, so the problem with the Kaggle dataset is the phase forensic datasets. It has a huge data. Okay, and we are not able to process that particular data. But yes, this will work 100%. This collab sheet will work 100%, and it will give us the same authentication, same output, because we have run it on our internal servers over here, workstation over here. So it will work, and it will give us some kind of output. But right now I don't have access to that system. So, but yes, there is a Cassia image tampering detection dataset that is available over here, and it is huge. Again, more than 3.52 GB, and I don't have that much of processing power right now. So we can't process that particular file. Even in the Google Colab also, it will take a lot of time. So I will leave this thing to you people. What you need to do, just I will explain it over here. So install all the libraries, and this thing will work at 100%. Okay, so if you have a GPU access, the CUDA cores, which are NVIDIA GPU that is installed on your systems, then it will work over here. Otherwise, it will work on the CPU part also. So there is no problem over there also. So it will detect, and then we have defined the data sets over here. So CIs are data sets, and then we have a forensic data set also. So it will get the insights from that particular data, and then it will do the image transformation. So there is a histogram transformation, or the resizing of the particular image. So let's say one image is captured. So when you are capturing the images, it will come different shape and sizes, just like other 250 cross 250, 500 cross 500. So we will making it a standard size, and then we are going to normalize all the images, and then we are going to load the data, and then we are loading this data also, and then we are going to, there is a ResNet of models, ResNet 50 models, which is the pre-trained models, pre-trained weights. So it's an entire machine learning kind of things. It will take 2-3 hours to understand this kind of things, and it is going to give us the binary and fake classification which are present over here. We are going to set the learning rate 0.001, which is a very slow learning rate. So it will take more than 10 hours, 15 hours to run that model. Uh, and then we have epochs also, number of epochs, and then we are going to train the data. So if you have access to good working stations, just download this data sets, two data sets, upload it over there, and see that how. So it will do a lot of good thing for you people, and then we are going to uh, single image, and then we are going to test. So what we would need to do, we need to replace over here with the help of that sample image that we have, this one. L- any sample image that we are going to do. So I have tested it, and uh, today the weather is not good over here. Uh, so I didn't get the access for that systems. But yes, so what you need to do, you need to copy this path, copy path, and where I have done, 1 second. Yes, so paste it over here, and what it will do, it will run the model, and it will done all the learning kind of stuff for you people, and it will give you the all the 1500 or output depending on this thing. So this is from my side. So we have done this thing also, this thing also. Okay, the hashing codes and all sort of things, fake news detection, cybercrime investigation, legal. So it has a huge application and huge expertise also, and it is giving us the questions, what should be the real world will look like, where the all the things should be capturing your data. And it's a very challenging thing for us to understand, and we give the insights related to the real world scenarios. And we need to develop some kind of solution also, so that the privacy will also not affect, and we will improve the technological advancements also. So it's questions that with the end of this question we are going to sum it up, that whether we are going to deal with the privacy uh, look at a first instance, or we are going to deal with the technology also, because it's disruptive in, or if you are not going to use, then again it's a problematic thing. So now I will uh, open for the few discussions, because I need. So this one is from my side. Thank you very much for your patience and listening. A few things might be you will get much more insights, much more better understanding related to the image forensics. Although this thing is not up to that mark, but yes, I have tried my best to provide the much more insights as per my capability, as per my resources, and as per my knowledge for this particular sessions. So thank you, and now I will open up for the questions and a few more discussions, and all the ppts and all the codes which are available over there. It's I will provide to organizing team also, and later on you will download it and get it and get your hands on practice over there also later on. And you can reuse this thing also, or you can distribute. If you want to distribute, you can distribute. I have no objection in this thing, because what I believe, knowledge is free to everyone, and you can distribute your knowledge and come much more insight. So thank you very much. Now this is all from my sides. Uh,
On the behalf of Faculty Development Program on Digital Forensics for Innovators, leveraging open source in cyber investigations organizing committee, I thank the respected FDP speaker, Dr. Ajay Sharma, for their valuable talk and hands-on the session. With the permission of FDP speaker, I am concluding the session. Thank you all. Thank you, sir.